Hi, this is Clay Green with PictureWindow Software, and today we're going to go through an overview of the SIP protocol, Session Initiation Protocol, which is used by a lot of voice over IP phone systems to communicate with regular telephones, SIP telephones, or to communicate with SIP soft phones. Really, there are a lot of devices. Auto attendants could be programmed to communicate over this using the SIP protocol. It's just a standard way that applications can communicate with a host processor, typically a PBX server of some type, for making, receiving calls, transferring calls, putting calls on hold. There are a number of features that are included in the specification for SIP that gives application developers such as PictureWindow Software a standard way to communicate with a number of different manufacturers' phone systems. For example, we're looking at TeleConnectSIP right here on the screen, which is a PC-based console or soft console, soft phone. It's a software-based telephone. With this application, your PC or your laptop becomes a phone. Everything that a phone does is done with this. If you look at an iPhone or if you look at an Android phone, they're really doing the same thing. They may or may not be using the SIP protocol to do it, but they're basically taking a computer, turning it into a telephone. And there are a number of advantages. We all know from using the iPhone that the integrated contact list or directory makes life a lot easier for us. When a call comes in, the phone automatically knows who it is and displays the name. And there's no need to really even have a network call party name display feature. The phone just does it for you because it knows that a particular 10-digit phone number is in your contacts. It makes a match and it brings up the name of the person. So we don't have to go around memorizing phone numbers in order to pick up our calls. So we're doing something very similar to that with TeleConnect or TeleConnectSIP, which is simply just the SIP version of TeleConnect, which is an application PictureWindow Software has provided for several PBXs over the years. Namely Nortel and Avaya, but with this newest TeleConnectSIP version, we work with Cisco, we work with Siemens, ShoreTel, Mitel, Microsoft Link, hosted environments such as 8x8, you name it. If it supports the SIP protocol, the application would work with it. So what we want to look at is what actually is SIP. And this is an overview, so we're not going to get that far under the hood of the protocol. We are going to have a future video on advanced SIP, which will be more geared for engineers, test technicians, maybe network technicians who are just getting into voice and want to know a little bit about SIP and how you can interpret, the packets that get sent to and from the application and the host PBX. So one of the things I want to show you first is how does my application know who it's communicating with? And I'm just going to show you one call just as an example here. Let's run a call in. Okay, here comes a call ringing in. There was a whole dialogue. I'm getting some feedback, so we're going to hit release. There was a whole dialogue that occurred when this call came in. Very quickly, let me show you a piece of that dialogue over here. All right, this is a program called Wireshark. Now, PictureWindow Software doesn't make that application, but it's available for free on the web. You can download it, and it's a network analyzer. It's a protocol analyzer. It allows me to see the messages that are going back and forth over my Ethernet connection. And when you start up Wireshark, you basically tell it the network connection you want to use, whether it's your wireless or your wired LAN connection, what filtering, do you want to see all messages, which is kind of a nightmare because there's so much going over the network, you really don't want to see it all. So you can filter it. What we're doing is we're filtering just SIP messages. I don't want to see anything else. So every time a message comes in over a particular port, which is 5060, the software, the Wireshark software says, hey, that's a SIP packet. It's using the default SIP port number. And you just saw something come in there. Mostly what's happened so far, you just see register messages and a couple of other things in between. Register occurs when the application first starts up. and it needs to connect to the host and say, hey, I'm a SIP phone and I'd like to, use your system. And I can tell who generated this message and who it was destined for using the source and destination fields here. There's also one other field that I don't care about for right now, and that's the time. There's a timestamp that is over all the way on the left. So basically, the first message occurred when I started up TeleConnect. It went out, and 45 is my IP address. .20 is the address of my Cisco Communication Manager, CUCM system 10.5, and my PC went and sent a message to the Cisco system and basically said, hey, I want to request service. I would like to register with you so I can start making and receiving phone calls. And the first thing that comes back is a trying message. And you can look here, that's coming from the Cisco system at .20 to my PC at .45. The Cisco system is telling my PC, hang on, I'm trying. And then the next thing comes back is an unauthorized message. And basically what the system is saying is you need to log in with an encrypted hash in order to log into my system. You can't just connect anonymously or with plain text. So that's expected. Every time TeleConnect starts up, it goes through the same process of trying to register and getting shot down with the unauthorized. But in this unauthorized message, the Cisco comes back and it tells it what MD5 hash to use and any other type of security protocol information that my application needs to know to connect to it. So the next thing my application does is it takes that information, it repackets its register request, and it sends it again, this time encrypting its username and password information into the packet. The Cisco comes back and says, okay, I'm going to try that again. And it says, you're good this time. You did what I asked you to do, you encrypted, and now you're in. So from this point on, my application is ready to receive calls. It's ready to make calls. There's a notify message that you see below the 200 OK messages. Basically, my application, is the Cisco system telling my application if it had any voicemail messages since the last time it logged in, and it will tell it how many voicemail messages. That notify message may contain some other information, but it's system specific. For the Cisco system, that's about all I get. It will tell me if I've got any voice messages that I haven't listened to yet, and if my voicemail flag is on or off. Okay, and then of course this is my application coming back and telling the Cisco, okay, thanks. So it's basically acknowledging every message that it gets. Now the other register messages, trying okay, register, trying okay, are all messages that happen periodically. From the time the application started, there's a little timer that occurs in the program. And basically that timer is set to re-register with the Cisco system before the Cisco system times out. There is a value over in the Cisco configuration that says any SIP connection that goes this long, and it's usually 1800 seconds, but it could be something less or more. If it goes 1800 seconds, let's say, and they don't re-register, consider that connection lost or dropped, that application closed, and it just didn't do any house cleaning with us. And we're supposed to do that. When we close, we're supposed to let the host PBX know that we're closing. If we don't do that, this is just a way that the host system knows that that application is disconnected. So you will see that periodically. The register request coming from .45, which is my PC, going to the Cisco PBX, and then the Cisco coming back with trying, and then with the OK message, and on it goes. Now, there's one thing in here that's not just a register request, and that is there's an invite here. We had a call that was, if you look, it's from .20, which is the Cisco PBX, to me at my PC.45. This is a call coming into my phone. And all calls come in via an invite message. It's telling my application, hey, I have a call for you. And if you look into, we're not going to go real deep into this today, but if you look into this invite packet, and this part of the screen is how you can look into a packet, you will see who the call is from. So your application could do some call presentation and let the user know, hey, you have an incoming call from extension 2010 or whatever it happens to be. All right. So I'm going to go ahead and just clear this screen off so we can make a call without having all the other garbage in there. And I'm going to restart the capture. You'll notice it goes to a blank screen, and I'm going to run a call into my software. So from a regular Cisco phone, regular telephone over here, I'm dialing 2002, which is the extension number of my console. Now you can see the result in my console. It's flashing, you know, I'm getting a flashing indication. It's in red. I'm going to click that to answer it, and I'm going to put this handset off hook so I don't get any echo, because that's annoying. Now, if you look here, I got an invite message from the Cisco system to my PC telling me I have a call and who it's from. And then the next thing you see is 45, which is my PC, telling the Cisco system, okay, I'm ringing that. I'm trying to reach that party now. And that's exactly what was happening. We were getting ringing there. Okay. The PC then sends the Cisco an OK message when that call has been answered, and the Cisco acknowledges that. .20 Cisco .45 me. All right. So you can see it's a very elegant, very simple system. What is being done with just 4 lines of information here is a whole call. If you went back to the old days with prior to any standards, working with a PBX at its native level, there were hundreds of messages that developers, such as PictureWindow software, used to have to decrypt, unencode, and give meaning to in order to make one phone call happen. There were standards that came about starting in the 90s, the late 90s and the 2000s. The TAPI protocol came out. It was popular because you could do a lot with it, but it had some drawbacks. One of the problems with the TAPI, which stands for Telephony Application Programming Interface, one of the problems with TAPI was that it required Microsoft to provide a driver, and it required the manufacturer of your phone system to provide a driver. And that driver from the manufacturer of your phone system might have been specific for each phone that you wanted to use an application like TeleConnect with. And you typically interface with those phones through some jack in the back of the phone, like a serial port, an RS-232 port. If they worked great, but oftentimes you might have started out on Windows XP, Windows 7 came out and the driver didn't work anymore. You had to go to your manufacturer. They didn't have a driver for it. That phone was now manufacturer discontinued. You were out of luck. You were now going to have to start again with different phones. When the manufacturer had a driver available, you could then purchase that driver. Sometimes you'd have to purchase that driver for each phone. So it got expensive, and it was a little bit kludgy. The beauty of SIP is that it doesn't require Microsoft to provide any kind of driver. So it'll work on Linux, it will work on Mac, it'll work on Windows, it'll work on whatever the next great system, desktop system is out there. It doesn't require any reliance on Microsoft providing a working driver, waiting for Service Pack 1 or 2 to come out before it works well. It bypasses all of that. It doesn't require a driver from your phone system manufacturer. And this was definitely a problem in the past, waiting for Nortel or Avaya to come out with the latest driver that worked with the current version of Windows for each of their phones. That was a nightmare. I actually had a company contact me and contracted us Because of that exact problem, they had a TAPI application that would no longer work because they upgraded their PCs to Windows. So that's a thing of the past. If you use SIP, there are still a lot of TAPI applications out there, so be careful. If you're going to go down that road, if you're going to look for an application like TeleConnect, there are TAPI variations of that still out there. We don't make one, but PictureWindow Software doesn't make one. We tested with TAPI. We were never crazy about it. I do have a lot of TAPI skeletons in the closet, so to speak, applications that never made it to general release out of Gate 3. But SIP is, there's some definite advantages to it. I love the fact that we just bypass all of those drivers that we used to have to deal with Microsoft, with manufacturer drivers, and we're communicating directly from my application over WinSock connections to the PBX. And it's so elegant that I can go ahead and change my configuration on the fly, and within 30 seconds I can be communicating with a different phone system. I have a Mitel PBX, Mitel 5000, sitting here in my lab. I could turn that on. I could go into my configuration in TeleConnect and simply change the IP address, the username, and the password, and I'm going to connect to one of the ports on the Mitel system. And I just want to show you a little bit. You saw a little bit about what the SIP messages look like over here. Hopefully you got an idea of what this communication is all about. Let me show you, how does my software know how to connect with this system? How does it know the IP address? There's a configuration screen for that. And I'm going to go into Tools, Options. I'm going to jump into my SIP tab, and I'm going to click on SIP Advanced, which provides me with a little debug window where I can make calls separate from the TeleConnect application. I can go ahead and put in either an extension here, or the nice thing about SIP addresses, that they could be just like an email address. music@iptel.org is actually a SIP address. And if I place a call to that, I'll actually hear music through my headset right now. And it's just a service that's out there on the internet. But more likely, if you were going to use this for testing, you'd set this up and put an extension number in here. But this isn't what I wanted to show you. It's the settings that I wanted to go into. This is how my software knows how to connect with the Cisco system. There's some options in here for the speaker and microphone, but right below that is the IP address of my Cisco CUCM 10.5 system. The user is my extension number. Password is the password that I'm going to use when I authenticate. Auth ID is my actual user ID. You can think of user as just extension number. This is actually my user ID that would be used for logging in for credentials. And there's the password. So it's kind of in flipped order here. The expire time, and this is one of the reasons that we see those re-register messages, is we want to re-register before this many seconds expires, or the Cisco system will think we've disconnected. Down here, the user agent is really an optional thing. You don't have to send anything, but basically this tells the Cisco system or the Mitel system that you're logging into, it gives it a name, it gives it a tag for this application, and in some cases those PBXs might load a specific SIP profile for a particular user agent. But there's always a default one that will be used if you don't specify a user agent, so that could have been left blank. And same thing with caller ID. We're going to send this number as a calling line ID when we make a call. But if we don't leave it in there, the Cisco system will use a default. It'll use my extension, which is 2002 anyway. The network interface that I'm going to use to make my connections is set for auto, but you could pick, I've got 3 different connections here, so you could have picked either your wireless or one of your wired NIC cards. I'm not using video, but the SIP protocol does support connections like a Skype connection for video calls. This is a list of the codecs that we're going to support, and I can check additional ones in here, but the most commonly used one for high quality voice in the United States is G711 MU law. G711A law is used in Europe and other countries. And I've got some specs here for the Dtmf tones. When I generate touch tones, if I'm going to connect with an auto attendant system or some sort of IVR system where tones have to be used to control the auto attendant, it specs out how I'm going to send those tones. So there are some other choices in here, but typically with just these 4 things selected, I've been able to connect with almost every PBX out there. The last thing that's important down here is the SIP listen port. You want to have the 5060 as the default SIP port number. If your system is using a different port number, you'd have to set that up. Otherwise, you're not going to be communicating on the port that the PBX you're trying to connect to communicates on. So you have to match what they're using. And it's that simple. Those few settings are all you need to connect to almost every PBX out there. All right. So this concludes the overview lesson. Whoops. Gonna hit a, oh, got this open. Okay, that concludes the overview lesson for SIP, for the Session Initiation Protocol, and I hope you enjoyed this lesson. Thank you.